Welcome back, data engineers. So in this next chapter, we're going to talk about the blood of NiFi, or the flow file. It's pretty much what streams through its vein. So I already prepped up my canvas here. And first, what we're going to do, we're going to demonstrate how can we create one flow file. We already done that in the past, but just for this demo, we're just going to use the generate flow file. So this processor has the capability to create a flow file, and it receives some parameters here, some properties that we can set the values: the batch size, the date format, the data format, unique flow files, and the custom text in this case. The character set, and the MIME type. So for now, what we're gonna do, we're just gonna leave this empty, and we're gonna link it to a downstream processor called update attribute. For now, that's all we're gonna do. On success, the generate flow file has only one output, in this case, success connection. So now let's talk about the flow file and what is the anatomy of the flow file. I prepped up a diagram here for you guys, and I'm gonna go through it as I will, let's say, point my mouse to the things and discuss a bit about the anatomy of a flow file. So a flow file is composed of it's composed of attributes and content. So attributes will be defined as key value pairs, and content is going to be your data, your let's say stream of bytes. It can be a text, it can be a byte data, it can be JSON, whatever you want it. So the content of the data, it's also represented in the flow file, but it's stored in the content repository, and it's represented in the flow file using a reference. So all the attributes that you carry in a flow file are stored in a flow file repository. So attributes in NiFi, they're really powerful because they provide information or context about the data. They're made up of key value pairs, and all of the flows, they have three standard attributes: the UUID, or the universal unique identifier, that distinguish the flow files from other flow files in the system. So it's I think it's a 32 digit or 16, I don't recall, but we're gonna see that next. The file name, which is a human readable file name that may be used for storing that particular flow file on disk or in any other external service. The path of the flow file, so it's in a hierarchically structured value that can be used when storing data to disk or an external service, so that the data is not stored in a single directory. So by design, all attributes are small, and ideally they should be small in order for NiFi to do its best work. The reason that is, most of the cases, they are loaded into memory. This way you can make use of them with ease. Attributes that are, I would say, again, going back to the use of attributes, they're the core routing when you're building your flow logic. You can also have attributes based on the content of the flow file. So in this case, you're getting a JSON file read into a flow content. Then you have the ability to parse that JSON content and then create attributes, key value pairs with using that. We're gonna see later on that it's a very common use case. So if you see here, going to the repository, the flow file repository blocks and the content repository are immutable. So what that implies, what that tells us immutable, what that actually means. It means that it cannot be changed after it gets created. So the fact that NiFi works with this immutable structure makes NiFi very fast, and it's a perfect fit for robust enterprise data flow. So content and flow repo both fall into the same category. So in this case, if an attribute changes in your flow, a new copy of the attributes are created in memory and written back to disk. Same for the content. When it gets changed, the flow file pointer is getting updated and point to a new block on the location on disk. In this case, this is where where I'm trying to actually draw that picture where the content claim, which is the object that holds the location of the content, we have a couple of information. We have the container, the section, identifier, and the offset. And what we're gonna do, we're gonna go over that in our short demo, right? So what does the last thing I want to add, what does the immutable capability brings to the table with NiFi? So out of the box capability to reply your data, meaning like if instead of me editing a particular object, I'm just making a copy including the added or removed whatever data is, it gives us the ability to go back and revisit that old object, and also we have the ability to replay them. OS caching out of the box, NiFi makes heavy use of that. Massive reduction in random reads and writes. That's really important. If you look at systems such as, let's say, SQL Server, they suffer with that because they're going through massive amounts of disk, fetching for particular locations on the disk to bring data out. That brings a lot of IO increase on the disk use, and also reduces storage requirements. And we're gonna see how that happens. All right, one of the container. Let's go and explain a bit what these terms mean: container, section, and identifier. So a container is going to be a section in your default content repository. So you remember at the beginning when we installed NiFi, we were talking about the ability to have the content repository or the Flowfile repository or the provenance repository set in multiple locations. If you leave it by default, then the name of it will become default, but you have the ability in the configuration to add multiple disks or volumes and tell the system that, hey, you have all these available locations to store my content repository or my flow repository. And we're going to see later on how we can change the definition of the NiFi properties to allow us to be more optimized. But that's going to be on a tutorial that we're going to talk about the NiFi optimization capabilities. All right, now the section. What is the section? In this case, if you see, the section represents this blue box. So a section is nothing more than just a directory under the default repository. And you're going to see that we have 1,000 default sections in the content repository. The identifier in this case represents the file that actually holds the content of the flow file, of one or multiple flow files. So that's another characteristic, and that's where the offset comes in place. You can have in the same let's say identifier or file, you can have multiple flow files written to. So that's going to be a copy on write executed one, because we talked about immutability, but now I'm telling you that you can have multiple in the same time. So what happens when you first add a flow file, and depending on the size of the content, NiFi decides to add to add new data to that let's say file by doing a copy on write, or create a new one depending on the size of it. And we're going to talk about this when we're going to reach optimization. That's, I would say, that's a bug that everybody's facing with NiFi when you have flows that deal with multiple flow sizes, flow file sizes. So let's say, for example, you have, I don't know, a megabyte flow content, and then that gets delivered, and then every 1 hour, for example, and then you have 100 very small one that is in terms of bytes. They will all fall into the same file identifier. Now, purging those files or reclaiming that area after the flow files are no longer in the system, it can be a nightmare for the garbage collector. But that's part of the optimization. All right, so let's now, because we already touched on it, what happens to the flow files after so let's say you have something flowing through the system, you've been processed, it reaches target, but now looking in the content repository, we see that we still have them there. So how the content repository cleanup work? So NiFi has a garbage collector like mechanism for the claims. That's how these structures are called, claims. If there are no flow files in my flow file repository pointing to the content, to any of the content in the content repository, then they will be deleted or archived depending on the configuration. We're gonna go over this archive configuration later in later tutorials, and we're gonna see how we can improve that let's say if you want to delete them faster, or if you want to archive them. But again, they both there's pros and cons when doing that. All right, so let's go over a quick demo to actually see how the content repository in the flow file is getting populated in a backend. Now that we touched on what is the composition or the anatomy of a flow file. All right, so I'm going to open my canvas, and I already pre-prepped flow file that will demonstrate this. So I'm going to remove that first part. And now, if you guys can see my screen here, I have a generate flow file. Actually, let me zoom in a bit. All right, this is good. So I have a generate flow file that will generate me small flow files, and I have one generate large file. So I have here 1 megabyte of text. It's pretty big. And then I have an update attribute. So I want to change some attributes there. And the attributes that I'm going to change the file name attribute. You remember, by default, we get an attribute called file name. Next, what we're going to do, we're going to open a command line, and we're going to jump into home directory of our NiFi installation. So it's going to be in opt NiFi. And we're going to keep an eye on this particular folder, our content repository. This is where the claims will be stored. So let's jump into the content repository, and let's list the folder. So you see here we have a bunch of folders. There's about 1,025 folders. And if we were to look for created files, so let me dig into this. So this command, what it will do, will go 2 levels deep into this folder structure, and he will show me everything but directories. So we can see right now we don't have any files created. Let's go into our front UI now, and let's generate some content by creating some new flow file. So what I have here, I have a very small content, which is going to be this particular text. I have a large one, which contains about 1 megabyte of data. And I have a very large one, that contains about 4 megabytes of data. So if you scroll down, it's pretty big. Now let's see how the content repository claims behave when we give them different types of content. So first, what we're going to do, we're going to generate one large file. So we're going to say run once. So you can see it's 1 megabyte payload. If we're going to go inside this particular item, we can see that it says that the content was claimed inside the container called default. You remember we talked about what each particular attribute means and how we can relate it to the operational system layout. So we have the section. We have the section is going to be one of those folders. The identifier is going to be the file that will hold the particular data, and the offset. Where does this start from? This might not be correct because I've just cleaned before this, so we can have a clean state. But anyway, let's look at it. So let's close this one and jump into our terminal and let's look for the file. So yeah, I'm correct. We just cleaned it, but let's actually validate that. So if you go to section 9 and we list for the file, there's none there. Yep. So let's actually force the creation and add another one. Now, if we look at this this second item, we can see that he is creating it in section 10. An issue would be, for example, I'll show you guys an example of a failure because prior to doing this demo, I've cleaned up the content repository manually. If I'll go to this this content claim here, he claims it's a 9 and 5 because this actually doesn't exist, and we're trying to view. We're gonna get unable to find the specified content. So that's the error message you get, or the when you're trying to see something that he cannot relate to, because the flow file generated has a relationship to this particular identifier in the content claim. So let's go to the second one. Now we have section 10 got generated, an identifier. It starts at offset 0, meaning it's the first content inside that particular content claim. If we want to view it, we can see it here. That's the original. We can even see it formatted, but it wouldn't make a difference. Now let's go to the operational system and see how that works. So let's use our find command again. This time, yeah, we can see that he actually relates to that particular location. We have section 10 and identifier is this one. Let's take a look inside it and see how it looks. It's gonna be pretty much what we saw in the front end. All right, so this is pretty much text. Now, let's go ahead with this in mind. Let's go ahead and add a new small flow. So if you look into this queue now, we can see that he attached it to the same content that previously was claimed by the other flow file. You guys remember we said that one identifier can hold one or multiple content, multiple flow file, content. And the way NiFi retrieves them is by using the offset that he's provided with. So if we look inside the definition of the flow file here, we can see that this is the offset that he starts from. So if we're going to look inside the OS, and we're going to do another cat on this, we can see that he appended this new small value that we gave it, that we gave to him. Now let's see what happens if we pretty much generate a very big content file. In this case, our 4 megabyte one. Right. I mean, it should append to this existing one because we said, hey, you know, you can have one or multiple flow files content in the same claimed identifier. Let's see if this is the case. We're going to jump into it and we'll look at the content claim information. Oh, he put it in a new section and the size is 4 megabytes. Now, the reason behind him putting it in a new section, there is a parameter in your, let's jump into our configuration file, configuration folder, and look into our NiFi properties, and let's search for claim. All right, straight up first parameter. So there is this property here that allows us to set how much he can append to a particular claim that he made previously. So we can definitely change this, but you have to be very careful. There are pros and cons depending on the data that you process and the chunks of data. It might be good to keep it as like this, or it might be good to increase it or decrease it. Ideally, you don't want to have a lot of files on an operational system that runs NiFi. Otherwise, you're going to get into issues. So let's close this one and get back to our content repository. So let's do again another find command. Now we see we have two content identifiers created. Let's go back to NiFi and let's see what happens if we do an update update attribute. And what happens to the content itself? Before we do that, what I'll do, I'll route these two connections to a dummy processor here, just for us not to lose the data in it, because we just want to see how each individual flow goes through. So let's run once and look at this. So we can see that there was no change. He stayed in the same section under the same identifier. The only thing that changed here was the new attribute, the file name, and the content did not change. So what we'll do next, let's force a content change. So this is a bit dirty here. Probably, I'll switch this one here so you guys can get a better view. All right. So let's see what happens when we run a replace text. So what we tell him here, actually this is incorrect. Let's say always replace entire text. That's all right. So we'll tell him look for everything that is inside that flow content and replace my value with this. So we remember we have new value, and what we're going to replace it with my new value. Actually, to make it more obvious, let's do this. Let's run this one and see what happens. If we look at details and we look at the section, we can see that he actually did a copy on write. So right now we are in section 12 and he initiated a new identifier in this case. So if you go back to our command line, you remember that immutability capability that NiFi provides. So yeah, we can see that we go into this file, we have a single value. Now, what's interesting about this, we can reply back to the previous, let's say, sort of container by using the reply capability, which we're going to demonstrate. But now let's see what happens next if we clone this to. So what I'll do, I'll revert this connection back to the update attribute. So what I'll do now, I'll have another replace that will pretty much replace that with another value. That's the value that he's gonna replace. So the replace value is not really important. We just want the content to be changed. And in this action, we add a funnel. The funnel, it will create it will pretty much create a cloning action. So what we'll do, we're gonna run this once, and you're gonna see that now we have two flow files with two content we're going to list this queue and we're going to jump into it. We can see that this was linked to the previous, to a new identifier in section 12. So going back to our, actually it's the same identifier. Sorry about it. So it's the same identifier. And by my find command, it pretty much tells me that he attached it to the same claimed identifier in our repo. So this one will have the same address. But if we look into the actual offset, you see we have offset 12 for this value. And here, if we look here, we should have a different offset. No, actually it's the same offset. So it makes a reference to the same value. Going back into the OS, if we do actually, let's go and do this cut. We can see we have another value as our placeholder. So this different flow files will make a reference. So you see here we have flow file details. That's our flow file ID. So it's let me just copy this one. So you can see they have different identifiers, but they will share the same location on in the content repository. Cool. So that's how contents are claimed inside the content repository and then are associated with flow files. Now let's go back. Let's go to this the second part where we're going to demonstrate NiFi replay capability. So in this case, what we're going to do, we have a small flow that will be created. So we're going to generate a new flow file. So we're going to call, it's going to carry a content of new small. And then we're going to go through an update attribute. Pretty much, we're just going to set pretty similar to what we did. And then we're going to make some changes to the content. So what I'll do, let's run this one all up to the end. So run once, run once. Now that we have this final payload, let's say, let's visit it and see what is the journey that this flow file goes through. So here we're going to go to provenance. Here we get a series of provenance event. They are ordered chronologically descending. So let's do this. So first we have a create, which was done by generate flow file. We have an attributes modified done by update attribute, and then content modified done by replace text. So let's jump into the show lineage and we're going to see some information. So the create time, if you click on details, we can see that there was no parent or child. No attributes have been modified in the first step. The content was added. There was no previous because there was nothing coming in. If we're going to go to update attributes, how we can identify what attributes were changed during this particular journey of the data point. We can see here in the attributes layer, we have this button show modified attributes. So right now, by selecting this, we're only left with the modified attributes. Also interesting, gives us a previous value. So previous value was this UUID, and now we have new file. And if we go to the content, we can see that there was no change in content. Content points to the same identifier, same offset, same size. And the connection ID is not important. Now let's save this. Let's close this one and let's go to content modified. We can see that nothing was modified at this step in terms of attributes, but the content was modified. The interesting part here, you can see the offset moved forward. That's the only one that moved forward. Now, let's say something happened here. The processing of that content change was not adequate, and I want to roll back that. So if you apply reply, if you click reply, what this will do, he will roll back the change. And if we're going to do a refresh here, you can see the upstream connection or queue got repopulated with that older content. Inside NiFi, this is really simple because he will make a reference to the previous offset inside that claim. So if you see here, new small, and let's say now, we want to change this logic. Let's say my new value 1 and start once. Another interesting thing I forgot to mention, though you're gonna roll back that particular content, the generated content of that previous action will still be there. So if you look into the queue, we're still gonna have that first one. Now we have this new content generated. See, it sits in the same identifier, same section, but the offset moved forward. So that pretty much covers everything I had to say about the flow file and its anatomy, how the content gets used by the flow files. And all right, so just to recap, we cover the flow files and how what's their anatomy, how a particular flow file holds its attributes in a flow file repository and the contents into its content repository. We discussed about the immutable let's say behavior, and then we did a short demo on how that actually works and how the content claims happen. We saw how you should not clean your content, otherwise you're gonna get into errors, like we did at that first stage. And then we went over some attributes that are showed in our flow files that point to the content claim. All right, so if you guys enjoy this content, I appreciate you give me a thumbs up, and if you're not yet a subscriber, please do so.